Hey everyone, welcome back to the channel. Today we're diving into Python essentials by covering scripting Python files, finding built-in modules, importing function from module, executing modules as script, email handling and reload function, and packages in Python. Let's start by discussing the concept of scripting Python files. The Python interpreter is great for executing individual lines of code, making it ideal for quick tasks or testing small snippets. However, for more complex programs, we organize our code into files called scripts. These scripts can contain multiple lines of code, allowing us to execute them as a cohesive program. To run a Python script, we simply pass the file as input to the Python interpreter, enabling efficient execution of larger structured programs. In this example, we demonstrate how Python scripts are executed using the interpreter. First, the programmer creates a script file named printname.py, where they define two variables, first and last, assigning them the values Larry and David. The script then uses a print statement to display the message hi, followed by these variable values. Programmers typically break down their code into multiple script files to keep related functions and logic organized. A module is essentially a Python file that contains code which can be utilized by other modules or scripts. By using the import statement, we can bring the content of a module into our script, making it accessible for use. Once imported, we can interact with the elements within the module, such as functions, classes, or variables, by referring to them with dot notation, like module.object. This approach helps in maintaining clean, reusable, and modular code. In this example, we demonstrate how to import and use variables from one Python file in another. The code is divided into two files for better organization. The first file, names.py, defines two variables, first and last, which are assigned the values Larry and David. The second file, printname.py, imports the names module using the import statement, which makes the variables defined in names.py accessible. In the script, printname.py uses dot notation to access the first and last variables from the names module and print them along with a greeting. When the script is executed with the command python printname.py, the Python interpreter loads the names module, accesses the first and last variables, and outputs Hi Larry David to the console. This example highlights how importing modules allows code to be organized and reused across different scripts. Now that we've covered the essentials, it's time to put your knowledge to the test. Ready to see how well you've grasped the concept of scripting Python files? Let's dive into some quick questions to check your understanding. Think carefully and type your answers in the comments for me to review. Here are the questions. Have you ever wondered what makes a file containing Python code executable by the interpreter, or how you can import one into another script? We'll explore how to reference objects from an imported module and what happens when you execute a Python file, making its contents available for use. Think about the questions carefully and share your thoughts in the comments. Review your answers and evaluate how well they match the concepts you've studied. Share in the comments how many you answered correctly and how certain you are about your understanding of the material. Next, let's dive into the concept of finding built in modules. When importing a module in Python, the interpreter first looks for a built in module, such as sys, time, or math, within the file system. If it doesn't find a match, the interpreter then checks the directories listed in sys.path, a variable within the sys module that contains a list of paths where Python looks for modules. These paths include the directory where the currently executing script is located, directories specified by the Python path environment variable, and the directory where Python is installed. It's important for programmers to avoid naming their modules after existing built in modules to prevent any conflicts, ensuring smooth execution and clear module imports. Now that we've covered the concept of finding modules, it's time to put your knowledge to the test. Let's dive into some quick questions to check your understanding. Think carefully and type your answers in the comments for me to review. Here comes the first question. When you use an import statement in Python, does the interpreter immediately check the current directory for a matching file? Think you know the answer? Here comes the second question. Can the Python path environment variable be set to specify additional directories where Python should look for modules? Check your answer and determine how well it aligns with the concepts you've studied. Share in the comments if it's correct and how certain you are about your understanding. Let's explore the concept of importing function from module. In Python, you can import specific functions, classes, or variables directly from a module instead of importing the entire module. This approach not only enhances code clarity but also reduces memory usage by limiting the amount of imported content. To achieve this, the from keyword is used in the import statement. For example, you can specify the names you want to import with a syntax like from module name import name 1, name 2. This allows you to access only the needed elements from a module, making your code cleaner and more efficient. This example demonstrates the difference between import X and from X import Y in Python. In the first step, when you use import mymod, the entire mymod module is added to the global namespace, but its contents remain within the module's namespace. To access specific elements like calc, you need to use dot notation such as mymod.calc. In the second step, this attribute reference operation allows you to interact with the calc function without directly importing it into the global namespace. However, in the third step, when you use from mymod import calc, only the calc function is copied directly into the global namespace. This means you can call calc directly without referencing the module name, making the code more concise. This example highlights how these two import techniques differ in terms of namespace management and accessibility. In Python, there are two main ways to import content from a module: importing the entire module or importing specific names. When you import an entire module using a statement like import HTTPS server, the entire module is loaded into the global namespace, and its elements can be accessed using dot notation, such as HTTP server address. This approach is useful when you need access to multiple elements within the module. Alternatively, you can import specific names directly from a module using the from keyword. For instance, from HTTP server import address imports only the address element from the HTTP server module into the global namespace. This allows you to reference address directly without needing the module prefix. Both approaches serve different purposes, with the first providing access to the full module and the second offering a more focused and concise way to work with specific elements. All right, after discussing the concept of importing specific names, it's time to test your skills. I'll present some questions, and I want you to think carefully about your answers. Comment your solutions in the section below, and let's see who's really nailed it. Ready? Here's your first challenge. Write a statement that imports only the factorial function from a module. Think you've got it? Here your second challenge. Take a close look at the code below. It's using functions, but the import statement is missing. Can you complete the import statement so that both factorial and squared are correctly used in the program? Let's see if you can crack it. Carefully check your answers and match them with the concepts you've studied. Share in the comments how many you answered correctly and how confident you feel in your understanding. Now, let's explore the concept of executing modules as scripts. Python modules can serve a dual purpose. They can be executed as standalone scripts or imported into other programs for reuse. When a module is run directly, its name variable is automatically set to main. This behavior enables the use of an if name equals to main block, where any code within this block is executed only when the module is run as a script, not when it is imported. This design allows developers to write modules that function both as reusable libraries and independent programs, providing flexibility and efficiency in code organization. The name special variable is automatically included in every Python module and plays a crucial role in distinguishing whether a file is being executed directly or imported into another script. When a module is imported, the name variable holds the name of the module. However, when the file is executed as a standalone script, the name variable is set to main. By using the if name equals to main condition, you can write code that only runs when the module is executed directly rather than when it's imported into another script. This allows you to create flexible files that can either function as reusable modules or as independent programs, depending on how they are run. This example highlights how the websearch.py module is designed to run either as a standalone script or as a reusable module, leveraging the if name equals to main construct. In the domain freak.py script, websearch.py is imported to perform web searches and process domain frequencies. The domain freak.py script prompts the user to enter search terms and retrieves search results using the websearch.search function. It then iterates through the results, extracting and counting domains, ultimately displaying the frequency of such results for each domain when the user exits by entering Q. Meanwhile, websearch.py contains the search function along with private helper functions like send request and get results, designed to fetch and process search results from a fictional search engine. The script includes the if name equals to main block, ensuring that when websearch.py is executed directly, it prompts for a search term, retrieves results using search, and prints the links found. This separation ensures that web-search.py runs independently when executed, but does not automatically execute its main logic when imported into domain freak.py. The output of domain freak.py displays the frequency of domains across all user searches, while the direct execution of web-search.py shows the search results for a single query, such as music videos, listing links found for that term. This modular approach provides flexibility and prevents unintended behavior. Now that we've explored the concept of executing modules as scripts, it's time to put your knowledge to the test. Let's see how much you've mastered, ready to showcase your skills. Take a look at these questions, and don't forget to drop your answers in the comments for me to check. Here's your first challenge. When you import a module in Python, does it execute all the statements inside the module automatically? Think carefully and share your answer in the comments below. Here's your second challenge. When a Python script is executed directly, is the value of its name variable always set to main? Share your thoughts below. Take a moment to review your answers and see how well they align with what you've learned. Let us know in the comments how many you got right and how confident you feel about your grasp of the concepts. Now let's dive into the concept of email handling and reload function. The email module in Python provides tools for managing email messages, including creating, parsing, and processing them. Module reloading, on the other hand, allows developers to refresh an already imported module during runtime, ensuring updates to the module's code are applied without restarting the entire program. The sendgmail.py program demonstrates how to send an automated email through Gmail using Python's smtplib and email.mime.txt modules. The program begins by importing the necessary libraries where smtplib is responsible for managing the SMTP connection, and MIME-text is used to construct the email's content. A predefined header introduces the email message, and the send function handles the process of sending the email. This function takes four parameters: the subject, recipient's email address, sender's email address, and the message body. Inside the function, the email is composed using MIME text, and essential metadata like subject, sender, and recipient details are added. The program establishes a secure connection to Gmail's SMTP server using port 587 and encrypts the communication with startles. After logging in with the sender's credentials, the email is sent using SendMail, and the connection is terminated. The program also includes a condition if name equals to main to ensure the send function runs only when the script is executed directly. When executed, the program sends an email with a specific subject and message, making it a practical example of email automation in Python. The modified sendgmail.py program illustrates the concept of dynamically updating email content while the program is running. The program begins by importing the SMTP lib module for handling the SMTP connection, and the MIME text class for constructing the email message. A header is defined with a default value. This is an important message from Johnny. The send function is designed to send emails by accepting parameters such as the subject, recipient's email address, sender's email address, and the email content. While the program structure remains similar to the original, the primary focus is on modifying the email content dynamically. When executed, the program sends an email with updated content, including the recipient's address, to, sender's address, from, subject, and message body. In this example, the email promotes a free Bratwurst coupon for loyal customers. This demonstrates the program's adaptability in generating dynamic, customized emails using Python. This program demonstrates the behavior of Python's reload function from the import lib module, specifically highlighting how reloading a module affects attributes imported using from import. Initially, the send Gmail module is imported entirely, and its header attribute is separately imported using from send Gmail import header. When the program prints the header, it displays its original value, hello. This is an automated email. The source code of send gmail.py is then simulated as being edited, updating the header value. After reloading the module with reload send Gmail, the header variable imported directly still holds the original value because the from import syntax creates a separate static copy of the imported attribute at the time of import. However, when the updated header is accessed through sendgmail.header, the changes are reflected correctly, showing the updated value, hello from Johnny's hot dogs. This demonstrates that attributes accessed directly through the module's namespace reflect updates after reloading, whereas explicitly imported attributes do not. Now that you've grasped the concept of email and module reloading, it's time to put your knowledge to the test with some practice questions. Take your time to think through each question, and please share your answers in the comments below. Here's a question for you. Can a module that has already been imported be reloaded? Let's find out what you think. Here's your next challenge. Does the reload function modify a module in place, or does it do something else? Take a guess and share your answer in the comments. Here's your last challenge. Is reloading a module a good approach when restarting a program is too costly or time consuming? Take a shot and see if you got it right. Review your answers and compare them with the concepts you've learned. Let us know how many you got right and how confident you are in your understanding of the material. Next, we dive into the concept of packages in Python. A package is essentially a directory that holds multiple modules, offering a structured way to manage and organize your code. When you import a package, you gain access to all the modules it contains. This organizational approach is especially helpful for larger projects, where grouping related modules together makes it easier to manage and develop the code in a modular way. By using packages, you can streamline your project structure, ensuring better maintainability and scalability. In this example, we explore how packages can group related modules together for better organization. The sound package contains sub-packages like music and effects, allowing you to logically separate different aspects of sound-related functionality. Once these sub-packages are imported, you can access the modules and definitions within them using dot notation. For instance, after importing the sound.music or sound.effects subpackages, you can reach specific functions or classes within those modules by referencing them with a dot. Similarly, the game package contains subpackages like sound and graphics, which organize game related functionalities like audio and visual effects. This structure helps keep the project clean, modular, and easy to navigate, ensuring that related components are grouped together for clarity and maintainability. This example illustrates a well structured directory setup for organizing art related modules within a Python package. The package contains a top level directory, rcart, which includes essential files like init.py to indicate it's a package. The canvas.py module provides the core functionality for rendering a canvas. Within ASCII art, there are two sub-packages, figures and buildings, each of which is dedicated to specific types of art. The figures subpackage contains modules like man.py and cow.py that define ASCII representations of characters and animals, while the building subpackage has barn.py and house.py for creating architectural elements in ASCII. Each subpackage also includes its own init.py file, marking it as a subpackage. The script draw scene.py imports the ASCII art package and uses the modules from the subpackages to create a scene. This directory structure promotes modularity and organization, making it easier to manage, expand, and maintain the project while ensuring that different categories of artwork, figures, and buildings are kept separate and logically grouped. The import methods presented here demonstrate the flexibility and clarity of Python's import system when working with packages and modules. First, importing the Canvas module from the ASCII package is done using the statement import ASCII-art.canvas, which grants access to the entire canvas.py module. When calling a function from this module, such as ASCII-art.canvas.drawCanvas, the full name of the module is required to specify the location of the function, providing clarity and avoiding any ambiguity. Next, by importing the cow module from the figures subpackage with from ASCII art.figures import cow, the prefix ASCII art.figures is no longer needed when calling functions within the cow.py module. This approach makes the code more concise and allows direct access to the cow module's definitions, such as cow.draw. This method simplifies the code when only a specific module from a subpackage is required. Lastly, the import statement from ASCII art.figures.cow import draw demonstrates an even more focused approach. Instead of importing the entire cow module, only the draw function is imported directly. This allows the code to call draw directly without the need for any package or module prefix, offering the most streamlined form of usage. Each of these import methods serves a different purpose depending on how much functionality needs to be accessed from the module or package, giving developers flexibility in structuring and organizing their code. All right, it's time to test your knowledge. Let's see how well you've grasped the concept of packages. Take a moment to think through each question and share your answers in the comment section for me to review. Here's a question to challenge your understanding of package imports. How would you go about importing the figures subpackage from the ASCII art package? Let's see who can get this one right. Here's your second challenge. Let's see how well you understand module imports. How would you import the cow module from the figures subpackage of ASCII art? Take your best shot. Take a moment to go over your answers and check how closely they match the concepts you've learned. How many did you get right? Let us know how confident you feel about your understanding of the material. In conclusion, we have covered the journey through Python's email handling, module reloading, and package organization. You've learned how to automate email sending, dynamically update content while a program is running, and how to effectively structure large projects using packages. By exploring these key concepts with hands on examples, you've built a strong foundation for writing cleaner, more modular, and efficient Python code. Now that you're equipped with these powerful tools, you're ready to take your Python skills to the next level. If you enjoyed this tutorial, please like, comment, and subscribe to our channel. See you in the next video.